Welcome back, everyone. Okay, today we are taking a journey that honestly every IT professional, cyber student, and power user just has to make at some point. We're doing a bare metal to desktop crash course in this explainer. We're going to look at exactly what it takes to transform a machine from just a lifeless block of metal and silicon into a secure, fully functioning modern workspace. We'll dive into the foundational architecture of Windows, the exact tools you need to deploy it, and how to choose the absolute best setup for your specific hardware.
So let's dive right into our roadmap for today. First up, creating a bootable USB. Number 2, formatting and firmware. Third, the evolution of Windows. And finally, choosing your Windows edition.
All right, I want you to picture the ultimate IT problem. You've just built this beautiful brand new computer, or maybe you just had to replace a completely dead hard drive. You hit the power button, the fans spin up, and literally nothing happens. No operating system, your machine is essentially just a very expensive paperweight right now. So how do you actually get Windows onto a totally blank drive that has absolutely zero software on it to begin with? Well, you need a bridge. And that bridge is the bootable USB. It's basically your IT skeleton key. It's just a simple flash drive, but it's specially formatted to hold an entire operating system's installation files. And it does it in a way that lets the motherboard boot directly from it, completely bypassing the hard drive. Without this, you can't install Windows, you can't repair a broken boot sector, you can't recover data from a corrupted drive, and you definitely can't upgrade. It is absolutely step zero.
Section 1, creating a bootable USB.
We're going straight into the matrix here, using the command line with a built-in tool called diskpart. Picture this kind of like a heist movie. You gotta get in, execute the commands flawlessly, and get out. You open the command prompt as an administrator, type diskpart, and run list disk. You find your USB drive, let's say it's disk 2. Next, you type select disk 2. Now listen to me carefully on this one. Your next command is clean. This instantly and irreparably wipes the entire partition table. There's no undo button here. If you accidentally selected your main hard drive, your data is just gone. But once it's clean, you execute create partition primary, you select it, and then format it. Finally, you assign a drive letter, type exit, and you're ready to drop your Windows ISO files right over. It's incredibly fast, it's powerful, but man, it requires total precision. Okay, let's all take a collective breath. As cool as the command line is, you don't always want to feel like you're defusing a bomb just to install an operating system. So let's put the terminal away for a second and look at the graphical user interface tools, the software that completely automates this high-stakes process for you. Today, we have these incredible GUI tools that take all that command line stress and turn it into literally just a few clicks. If you're a beginner, the official Windows Media Creation tool is a totally zero-friction way to get an authentic Windows installer right from Microsoft. If you've got a custom ISO file and you just want a simple 3-click process, Belima Etcher is incredibly beginner-friendly. But if you want blistering speed and some really advanced control over your firmware targets, Rufus is basically the gold standard. And finally, for the IT pros out there, there's Ventoy. I love this one. You install Ventoy on a USB just once, and then you can drag and drop as many different ISO files as you want right onto the drive. It turns a standard USB into the ultimate multi-tool boot menu. Section 2, formatting and firmware. It is actually fascinating to see why so much older troubleshooting advice just totally fails on modern hardware. Basically, we have two main partition styles. First is MBR, or Master Boot Record. This is a standard straight out of the 1980s, and it has a very hard ceiling. It literally cannot read a drive larger than 2 terabytes, and it maxes out at just 4 primary partitions. Compare that to the modern standard, which is GPT, or GUID partition table. GPT supports practically unlimited drive sizes. We're talking over 9 zettabytes here. Plus, it allows for 128 partitions. It even stores backup copies of your partition table, meaning if one sector gets corrupted, it doesn't just instantly kill your whole drive. But here's the catch. You can't just pick GPT or MBR at random. They're strictly tied to your motherboard's firmware. If you have an older PC running legacy BIOS, well, it boots up in a 16-bit environment and it absolutely has to pair with an MBR partition. Modern PCs, however, anything built in the last decade, use UEFI. UEFI is graphical, it's much faster, and it requires a GPT partitioned drive to boot modern Windows. Even more importantly, UEFI supports Secure Boot. That ensures only digitally signed software is allowed to run before the OS even starts, which completely blocks nasty things like rootkits. So UEFI and GPT, they are a mandatory team for modern systems. And sitting right on top of all those partitions is the file system.
You can think of these kind of like different types of luggage. NTFS is the vault. It has advanced security, journaling to prevent data loss, and supports absolutely massive files. But it's really only meant to stay on Windows drives. Then you have FAT32, which is the tote bag. It's universally recognized by pretty much every device out there and is the safest bet for UEFI boot drives. But it comes with a strict 4 GB weight limit per file. So if your Windows install file is 5 GB, the tote bag rips and your copy just fails. Finally, exFAT is the suitcase. It's perfect for modern flash drives that need to move between Windows and Mac, offering you massive capacities without that annoying 4 GB limit you get with FAT32.
Section 3. The evolution of Windows.
Let's jump back to 2012 with Windows 8, which really shocked desktop users by totally replacing the Start menu with a full-screen, touch-focused tile UI. Talk about a massive learning curve. Just a year later, Microsoft pivoted with Windows 8.1, bringing back the Start button and letting users actually boot directly to the desktop again. But Windows 10 in 2015 was the real unifier here. It brought back the true Start menu, introduced virtual desktops, and added DirectX 12 for the gamers. Then finally, we arrive at Windows 11. Now, the absolutely crucial point here is that Windows 11 completely changes the baseline. Yes, it forces modern UI changes, but more importantly, it strictly requires a TPM 2.0 hardware chip and UEFI secure boot. And look, this isn't just Microsoft trying to sell you new PCs. It is to create a hardened defense against firmware-level attacks that software alone just cannot stop.
Section 4. Choosing your Windows edition. Okay, let's break this down by looking at 3 main avatars. First up, the gamer, or the everyday user. You're going to want Windows Home. It's lightweight, it's perfect for standard tasks, but keep in mind it's capped at 128 GB of RAM, and it lacks some advanced tools. Next, we have the cyber student, or the power user. For you, you absolutely need Windows Pro. Pro unlocks Hyper-V for creating your own virtual machine labs, it gives you Windows Sandbox for safely testing sketchy files, full BitLocker encryption, and it bumps that RAM limit up to a massive 2 TB. Finally, we have the corporate IT admin. For them, it's all about Windows Enterprise. You actually can't even buy this as a consumer. It requires volume licensing and features central domain management, elite security tools like Credential Guard, and supports a totally absurd 6 TB of RAM. Which brings us to the very end of our deployment journey today and leaves us with one final important question. Is your current operating system holding you back? We've seen exactly how the right bootable USB unlocks the door, how matching UEFI firmware with GPT partitions allows for massive, highly secure drives, and how choosing Windows Pro over Home might honestly be the only thing standing between you and a functioning virtualization lab. You now know exactly how the architecture of Windows works, all the way from the bare metal right up to the desktop. So I highly encourage you, as soon as this explainer is over, open up your system settings and check for yourself. What firmware, what file system, and what specific edition are you really running?